All right, so we're talking about vectors, everything there is to know about them, at least for pure mathematics. So the prerequisite, first of all, is the fact that you need to know how to define a vector. There's a column vector form, which looks like
Mm-hmm.
this, and then there's a IJ form, which looks like this, right? Both of
Mm-hmm.
these mean the same thing. This is the x component, and this is the y component. Similarly, this is the x component, and this is the y component.
Okay.
On a graph, it'll look like this. Uh, A will basically be, like how far horizontally the vector is going,
Mm-hmm.
and B will be how far vertically the vector is going. So the vector
Okay.
will look something like this. Okay. This
Okay.
is all prerequisites, by the way, again.
Mm-hmm.
So this is the J direction, this is the I direction. Another thing to remember is that a vector does not care about its position. Okay. So you can pick this
Mm-hmm.
vector up, put it anywhere. It's going to be the same exact vector. Okay.
Okay.
But we like to start them at the origin because for obvious reasons. Because now we can see this value and this value from zero, so it just makes it convenient. But
Okay.
this is how you define a vector. This is stuff that you need from beforehand. Now,
Mm-hmm.
um, the first thing is, what is a, a displacement vector? A displacement vector is simply a vector that specifies, displacement basically. So change in
Okay.
position essentially. So for
Mm-hmm.
example, if I tell you that a person has a displacement vector, AB, for instance, equal to 4, 3, that
Mm-hmm.
means they move 4 units in the x direction and 3 units in the y direction. So they moved in that direction. Okay.
Okay.
So this, I'm giving you a direction and I'm also giving you a distance because the
Mm-hmm.
length of this vector specifies the distance they have moved. Okay.
Okay.
So that is what a displacement vector is. Um, and again, just to specify, you can also define a vector in 3D by just adding another component to AB or AIBJ. So for example, a 3D vector would look like this. So A, B, C, for example, right? So the
Mm-hmm.
C is the third direction because now you're talking about three directions.
Mm-hmm.
Similarly, we say AI plus BJ plus CK. So K is the third direction. On
Okay.
a graph, now we will need a 3D graph. Okay. So we will
Mm-hmm.
have a I direction, a J direction, and a K direction, and a vector could be defined as anything in this space like this. So the edge, the tip of the vector will be at this point in 3D space. Okay.
Okay. Mm-hmm.
Now, enough setting up. Let's talk about some ideas now. Um,
Okay.
the first thing is that okay, there's two ways to there's two notations we use for a vector. So a
Mm-hmm.
vector, we can define it as the vector from 2 points, like sorry, between 2 points from, for example, A, B. So if I make a vector that goes from A to B, I
Mm-hmm.
can call this vector AB with a little arrow on top of it to specify
Mm-hmm.
that it's a vector and not just a line. But sometimes we also name vectors with small letters with an arrow on top. Okay.
Okay.
So you can also name them, but this one doesn't specify the fact that it's going from A to B. So as you can see, this is clearly a bit more informational. It tells you a bit more about the
Mm-hmm.
vector. But you can
Mm-hmm.
also call them small a. But just remember to put an arrow on top. Otherwise,
Okay.
they are not vectors, they're just straight lines.
Okay.
Okay. So far, we've only talked about notation, etc. Now let's talk about parallel vectors. How
Mm-hmm.
do you check if two vectors are parallel? Now, technically, a prerequisite to understanding about parallel vectors is scalar multiples of vectors. So scalar numbers, by the way, are just regular real numbers that you've worked with, multiples of vectors. Now imagine that you have a vector 1, 3. Okay.
Mm-hmm. Mm-hmm.
This vector looks like this. It's gonna have a 1 in the x direction and 3 in the y direction, so it's gonna look something like this. Okay. So we
Okay.
can call it vector A for now, and this is vector A. Now, we can find the magnitude, which is also the length, by the way, of vector A by simply using Pythagoras theorem, squaring each of these and adding them up in the square rooting it. Okay. So
Mm-hmm.
this tells you the length of the vector, also called the magnitude.
Okay.
Okay.
Mm-hmm.
Same thing. So in this case, we end up with 2, a length of 2 units. So the length of this vector will be 2 units. Now, let's say we make a new vector, which is essentially the same vector as before, 1, 3, but we multiply it by 2, or let's say 4. Okay.
Okay.
Now, scalar multiplication. So we've basically multiplied our vector with a scalar. This is a scalar number, right? So
Mm-hmm.
what the vector becomes is 4, 12. Thankfully, multiplication works the same as in algebra. So you can just multiply them by 1 and 3, and you get 4, 12. This
Okay.
vector will now look like this. It's 4 in the x direction and 12 in the
Mm-hmm.
y direction. So it looks like that. Okay.
Okay.
Now
Mm-hmm.
here's the interesting thing. If you find the magnitude of b, it will be 4 square plus 12 square, oops, 12 square with a square root over it, which would
Mm-hmm.
give you 16 plus 144, which is something 16 plus 144 with a square root. It gives you 4 root 10. Okay.
Okay.
Which makes me believe that I've actually calculated this wrong because 3 squared is 9, 9 plus 1 is 10, so this is root 10. So I've
Mm-hmm.
miscalculated this. And as you can see, something interesting. What do you notice about the magnitude of A and the magnitude of B?
Um, they're
Magnitude of B is what factor of magnitude of A?
4.
Exactly. And as you can see, B, the vector B, is 4 times vector A. So what we've
Mm-hmm.
learned here is that upon multiplying a vector by a scalar number, all you change is its length. You do not change its direction because you're multiplying the x and the y by the same number. So you just make it longer or shorter, but depending on what you multiplied it with. Clearly,
Mm-hmm.
the magnitude changed by the exact same factor as the vector as the factor that you multiply the vector with.
Yeah.
So the point is that when you create multiple scalar vectors, vectors that are scalar multiples of your vector, you're simply going to
Mm-hmm.
adjust its length. You're going to change its length, nothing else. Okay?
Okay.
So these two, A and B, are parallel because
Mm-hmm.
they only are longer and shorter versions of each other. So what we've learned is if you can prove that two vectors are simply scalar multiples of each other, you have automatically proven that they are parallel vectors. Okay? Let me
Okay.
show you an example. For instance, I want to check if this vector and this vector are parallel. Are they parallel?
Mm-hmm.
This question is equivalently written as are they scalar multiples
Okay.
of each other? Because this is easier to check. I mean, this is the way you check if these two vectors are parallel. How do you do it? Basically, factor out the biggest number that you can factor out of 2, 4. What's the biggest common factor between 2 and 4?
2.
What's left inside?
1 and 2.
Good.
Mm-hmm.
And what's the biggest common factor for minus 16, minus 32?
Um, 4.
No.
I don't know. Um, 6.
16 doesn't divide by 6.
Yeah. Not sure.
By 16 itself. Because when you take out a minus 16 from this, what are you left with? Minus 16 times
Minus
1 is minus 16, and minus 16 times
Mhm.
2 is 12, which means that
Mhm.
this guy and this guy, they're just different scalar multiples of the same vector, right?
Okay.
So you
Mhm.
take 1, 2, and you make it double as long, you will get the first vector. If you make it minus 16 times as long, you will get this vector. So they're
Okay.
simply same vectors, sorry, same directions, but just different length. What does minus 16 mean, by the way? What do you think? Like 16, I know what that means. If you multiply a vector by 16, you like make it longer by 16 times. But what does minus 16 do?
Um, it just subtracts it or
No. So, like, if you take 1, 2, that looks like this.
Mhm.
If you make, so this is 1, 2, right? So 2 times 1, 2 would just be double that long. So this
Okay.
basically. So what does minus 16 times 1, 2 mean? That means the negative flips it. It changes, like it makes it turn the opposite way. So it's going to be
Okay.
16 times as long in the opposite direction. Okay?
Mm.
Because remember, vectors have directions. Okay?
Okay.
Because now you're saying that it's 1, 2 in the negative direction with 16
Mhm.
times the length. So that is how you can check if two vectors are parallel. Just check
Mhm.
what happens if you take out the biggest common factor out of both of them, do they become the same thing? And the leftover part, is that the same thing? Okay?
Okay.
And that's it. So this is everything you need about parallel vectors.
Okay.
Um, the next idea is how do you add vectors? There's two ways to add, like think about adding vectors, adding and subtracting vectors. There's two ways to think about it. The first way is easy. It's the algebraic way.
Mm-hmm.
Makes life super easy. If you have two vectors like A, B, and then you want to add it to C, D, just add A to C and B to D. That's it. A plus C, B plus D, and that's the answer. Okay.
Okay.
And
Mm-hmm.
similarly, you can write down the same question as AI plus BJ plus CI plus DJ. And you can do the same thing. So you're going to have A plus CI, right? Because A plus CI, and
Mm-hmm.
then plus B plus DJ. This tells you the same answer basically, right?
Okay.
So this is easy.
Mm-hmm.
But then there's the graphical method, which I don't think you'll ever need in an exam, but maybe, I don't know. So you make the two vectors. So like for example, you have 1, 3 and 2, 5, for instance, okay?
Okay.
So um actually no, that's not graphical if I'm giving you numbers. The graphical method would require that you have the graphical representation of the two vectors, and that's all you have, okay? For example,
Mm-hmm.
A and B. You have to simply use the head to tail method, which means that you have to put every single vector so that every head is connected to a tail, like this. Okay?
Okay.
Or you could have, put it like this. As long as you don't make the mistake of putting them with head attached to head like this. As long as
Mm-hmm.
you have head to tail, you're fine. Okay?
Okay.
Any way works. Then simply start at the first tail and reach the last end and add up everything in between. So A plus B. So this vector that you get in the middle from the
Mm-hmm.
tail to the this vector, this
Mm-hmm.
is the sum of A plus B. This vector is the vector you will get if you add A and B together. Okay?
Okay. Okay.
And similarly, subtraction would work the same way, but with one little difference. You have A and you have B, but you want to do A minus B, right?
Mm-hmm.
So the first thing you want to do is you'll have to find out what minus B looks like. Minus B looks like the same thing as B, but in the opposite direction. Then do
Okay.
the same thing. Just put head to tail, and you get this vector from here to here. This is A minus B. Because see, A minus B.
Okay.
So this is the vector you will get if you subtract A and B from each other. Okay.
Mhm.
This is how
Okay.
you can do graphical additions and subtractions. I'm not sure if you are ever going to be asked this in an exam because it's a sketch, and in
Mm-hmm.
pure math it's mostly numerical, so I don't know, but you should know this. It's called the head to tail method basically.
Okay.
Yeah. Okay. So now, in general, the notation is that, for example, if you have AB and you have BC and then you have CD and you have these vectors are given and you want to find the vector from A to D, okay?
Okay.
What you have to do is you have to think about how to get from A to D by using only like these movements, okay?
Mm.
So in this
Okay.
in this question it's easy because you just have to do AB, and then from B you go to BC, from C you go
Mm-hmm.
to CD, you add all everything in between and you will get A to D. Basically first tail to last head. Okay?
Oh, okay. Okay.
So again, not very important for the questions we
Mm-hmm.
will be seeing in the exam. This idea is not very important. Um, okay. So now let me show you some kind of questions that show up in exams. We've
Mm-hmm.
already talked about the magnitude of vectors, right? Just
Yeah.
just to clarify, magnitude of a vector, whether it's 2D or 3D or 4D or 10D, the
Mm-hmm.
formula stays the same, okay? You have AB, simply square each of the components and add them up and square root them. If you have ABC, again, square each component and then square root the whole thing. So this
Okay.
comes from Pythagoras theorem, by the way, if you want to know,
Mm-hmm.
because if you make a vector like this one, and you know its horizontal part and you know its vertical part, You can
Mm-hmm.
make a right angle triangle like this, which is a x of a and y of b. You can find this length, which is the magnitude, the length of the vector, by using Pythagoras, a square plus b square square root. So
Okay.
that comes from Pythagoras theorem. Just background information here.
Mm-hmm.
Um, so far everything making sense?
Yes.
Perfect.
Mm-hmm.
Next idea is the unit vector. So a unit vector is defined as any vector with a magnitude of 1. Okay?
Okay.
Any vector that has a magnitude of 1 unit, basically, that's why we call it unit vector. The
Mm-hmm.
reason, by the way, we say 1 unit is because we don't have a centimeter or meter thing for vectors. We just say 1 unit. Okay?
Okay. Mm-hmm.
So any vector that has a magnitude of 1 unit will be called a unit vector. Now, we can convert any vector to a unit vector, okay?
Mm-hmm.
Because if you take any vector and you shrink it down so that it's just the same the same direction but 1 unit long, it's become a
Mm-hmm.
unit vector, right?
Yeah.
But how do you do it? How do you change the magnitude of a vector? Any bells? Something I've told you already, maybe? How can you change the magnitude of a vector? How can you change the length of a vector?
The scalar factor thing?
Beautiful. Exactly. If you multiply a vector by a number, you will be multiplying its length by that number, really. The
Yeah.
direction stays the same. So what if I divide a vector by its own magnitude? Wouldn't I divide its magnitude by its own magnitude as a result, causing
Yeah.
its magnitude to become 1? That's
Yeah.
exactly what we do. To convert
Okay.
any vector to its unit vector, just divide it by its own magnitude. Because you will
Mm.
basically end up dividing the vector's magnitude by its own magnitude, which will make the magnitude of the resultant vector 1, hence giving you UA. I believe that's the notation. Let me make sure. Ah, no. It's A with a hat on top of it.
Okay.
Hat means unit vector.
Mm-hmm.
Okay.
Okay. Got it.
So you can do this. Like I'll show you an example maybe.
Mm-hmm.
For instance, you have they will say find a unit vector in the direction of root 5, 2. Okay.
Mm-hmm.
So that means we want to make this guy a unit vector because we want the direction to be the same as this, but we want the length to be 1. Okay. So
Okay.
we have to divide this guy by his own magnitude. What's the magnitude of this vector? You tell me. How do I find
Um,
it? hmm
do we have to just find the multiples of it?
No, no, the magnitude. So the
Oh,
formula from earlier.
square root of 5 squared, plus 2 squared, all square rooted.
Exactly. Which is going to give you 5 plus 4, which is 9. 9 square root is 3.
Okay.
Okay.
Mm-hmm.
Which
Mm-hmm.
means that, so for example, if this is vector A, then A hat would simply be what?
Just 3.
No, no, no. That's the magnitude of the vector. But if we want to
Okay.
make the unit vector, we would need to divide the vector we have by its own magnitude, which is 3. So what would the resultant answer be?
So 5 square root of 5, just both of those numbers divided by 3.
Exactly. Root of 5 over 3, 2
Oh,
over 3. You can
okay.
also write it like this, by the way. Just keep the 1 over 3 outside
Mm-hmm.
because it means the same thing. You can. So
Mm-hmm.
just remember this. It means the exact same thing. So this
Okay.
is the unit vector in the direction of root 5, 2. That's it. Because the
Okay.
original guy had a magnitude of 3, but we wanted it to be 1, so we divided the vector by 3 to make the
Mhm.
magnitude 1.
Okay.
Now, that's basically it. Let's do a
Mhm.
question now that is similar to something you can expect in an exam.
Okay.
So here. So you can ignore this and this for now. So you
Okay.
have a regular octagon, okay?
Mm-hmm.
Some vectors are given to you. You've been told that AB, the vector from A to B, is called P. The vector from A to H is called Q. The vector from H to G is called R. And the vector
Mm-hmm.
from H to C is called S. Now,
Okay.
using these vectors, we want to find the vector notation for BC. Okay. Now, what I want you to do is, these questions are very easy actually. They
Yeah.
want you to find out this vector, right?
Yeah.
All you gotta do is, you don't know what this vector is, but you know everything around it. So start at B and find
Mm-hmm.
another route to get to C and add everything you see in the way. Okay?
Mm-hmm.
So go for it.
So vector BA,
which is
P. So
negative P.
okay, because it
Because,
goes in.
yeah, AB is P, so BA would be negative P. Because
Okay,
you're
so
going the other way.
mhm. Negative P plus negative Q.
No. Now you're
Oh,
going the
Q
same
is
direction
going
as
up.
Q.
I see
Yeah.
the arrows now. Okay,
hmm
so just Q and then plus S.
Exactly. So that's BC. Perfect.
Mm-hmm.
What is that? Is that EB? I think it's EB. Let's try to
Mm-hmm.
find EB now.
Okay, where's
So we want to find, oops,
E?
this guy. So start at E, go to B. Remember, the fact that you know what this is means
Mm-hmm.
that you also know what this is because they're exactly the same vector. Remember, position does not matter in vectors. So this is also P. So
Okay,
is
as
there
a
any other vector you know, by the way? Because of
um
the, uh-huh,
yeah, so I can know FG, right? Because
beautiful. What is FG?
it's Q.
No, because these are not
Oh,
parallel. So you got to
oh,
find something that's parallel to GF. AH
oh,
is not
okay.
parallel.
Oh,
See, AB and FE are parallel. That's why I said they're P.
okay.
Parallel vectors are equal, basically. Parallel and
So,
equally long vectors are equal.
mhm. So that's parallel to BC.
Exactly. But is FG parallel to BC or is FGF parallel to BC? Like the
Um,
direction matters.
okay, it's not. It's like the opposite of the direction that BC is
Exactly.
going.
So let's say GF is BC, right? Isn't that true?
Okay. Yeah,
Because yeah.
you can see that.
So hmm so now try to get from E to B without crossing EB.
All right. So we're E to B. Okay. So it's plus, so
Careful.
it's negative P,
Okay.
plus, can I just say Q?
No, but that's not Q.
Oh, sorry, plus BC.
But now you're not going in the direction of BC. BC is from
Mhm.
G to F. You have to go
So,
opposite to BC. So you should say minus BC.
okay, minus BC and then minus R
Mm-hmm.
minus Q plus P.
Exactly. So now we can
Okay.
do some simplifications here and put BC back in where it belongs, right? Because we know what BC is from
Yeah.
earlier.
Mm-hmm.
So let's replace BC with what it is. By the way, before we do that, minus P and plus P can cancel each other out.
Mm-hmm.
So now we have minus of everything that BC is,
Mm-hmm.
and then minus R minus Q. Okay.
Okay.
Now what is
Mm-hmm.
this going to become?
Um, P. It's just like times everything. So
Yeah,
P R.
exactly.
Oh yeah, P R.
What? No, no, no. You're just opening up the negative for now.
Oh, okay. So just
Yeah.
P minus Q minus S.
And then the minus R and minus Q, they're not multiplying. They're just sitting there,
Yeah.
subtracting. It's not like R is here or here,
Mm-hmm.
right? Minus
Mm-hmm.
R. So that's it. And then we can, simplify this by adding the Q's together and we
Mm-hmm.
get this. And this is how you can solve these kind of problems, okay? Just
Okay.
remember the sign matters. And
Mhm.
once you know a vector, always remember you probably know many other vectors due to it. For example, since you know Q, this is Q, you also know that this is Q.
Mhm.
As a matter of fact, there's another way to do this question, which is easier, I would say now,
Okay.
because we know this is Q,
Mm-hmm.
we know this is R, and
Mm-hmm.
we know this is BC. Actually, it would give you the same exact method as before. And we
Okay.
know BC, right? So we can go like this also. We can
Mm-hmm.
say that EB is minus Q minus R minus BC. That
Yes.
would have given us the same answer as before.
Okay.
There's always a bunch of ways to do these. Now, the next question is explain why S is a scalar multiple of P.
Okay.
So why do you think S has to be a scalar multiple of P?
Mm, because it's times two. Is it?
But you don't know that yet.
Yeah.
You
How do
can't
I?
just conclude that, but y- you don't know, like regardless of what K is, why
Mm,
must S be a scalar multiple of P? Why is that a requirement?
mm,
So what does being a scalar multiple of another vector mean? What does it mean about the relationship between the two vectors?
they're parallel.
Exactly. And clearly we can see that S is parallel to P.
Okay.
right? Since S is clearly parallel to P, it
Mm-hmm.
must therefore be a scalar multiple. Since
Okay.
S is parallel to P, that's the answer. Now we need to find the exact value of K, which is definitely a more fun-looking question.
Okay.
Um, let's think about this.
Mm-hmm.
So maybe well, the first thing we should do is try to find out what S is in terms of, P, Q, and R. Okay?
Mm-hmm.
Because if we
Okay.
can find out what S is, then maybe we can think about, the relationship between S and P. So can you
Okay.
help me figure out a way to define S without using S itself?
Okay. Mm,
Start at the beginning of S, go to the end of S somehow without going through S.
okay. I can do to S to C and then C to D, like that
Uh,
direction. That work?
S to C, what do you mean?
Or mm,
You can't go down this line. You have to start here and end up
mhm.
here somehow by either going like this or like this, etc.
Okay, so Q, no, negative Q,
Hmm.
plus P, and then plus BC.
Which we know as from earlier, so we can just plug it in
Mm,
directly. So
okay.
plus BC would basically mean minus P plus Q plus S,
Mm-hmm.
which gives us negative Q plus P minus, we're stuck.
Okay.
Okay, we're gonna get an interesting situation. We're
Mm-hmm.
gonna get S is equal to S, which is useless for us,
Yeah.
right? Okay,
Okay.
so we need to figure out the actual, like, we need to figure out how much longer S is than P. Okay,
Okay.
so maybe we can think about it like this. Um, of course, this part of S is P, right? I mean, this
Mm-hmm.
is the same length as P. Okay,
Mm-hmm.
but we need to know what this length is and what this length is now. Okay,
Okay.
so what we can do is, we know that this is one, the length of this is one, for instance, right?
Mm-hmm. Mm-hmm.
Let's consider it to be one.
Okay.
Because it's a regular octagon, we can call it one for now. Okay. If this
Okay.
is one, and obviously these two are equal, right? Because it's perfectly symmetric. Everything is symmetric. So these two have to be equal, which
Yeah.
means that I can use Pythagoras to find this length and this length. Okay.
Okay. Okay.
So I will say that 1 square equals x square plus x square, which leaves me with 1 equals 2x square, which leaves me with 1 over 2 equals x square, which tells me that x is 1 over root 2. Hence,
Okay.
I found out that this length is 1 over root 2, and so is this,
Mm-hmm.
therefore, right?
Okay. Mm-hmm.
Which tells me that so if p is 1, the length of p is 1, if I assume that p is 1, then the
Mm-hmm.
length of s is therefore 1, which is p, this part,
Mm-hmm.
plus
Yes.
1 over root 2 plus 1 over root 2, right?
Okay. Mm-hmm.
So we're going to end up with um, 1 plus 2 over root 2, right? So
Mm-hmm.
this is how long s is, and this is how long we've assumed p is. So clearly, if I multiply p with this number, I will get the length of s, right?
Mm-hmm.
So we don't need this. This was pointless. So how much longer than p is s? Like what factor? If I multiply p with 1 plus 2 over root 2, I will get s
Mm-hmm.
basically. That's what I've
Yeah.
learned,
Yeah.
right? Because that's the like multiplication factor that would give me the length of s. So
Mm-hmm.
I found out that s is equal to this much times p. So I
Mm-hmm.
wasn't supposed to use any vectors here. I was just
Mm-hmm.
supposed to use basic geometry. Okay?
Mm-hmm. Okay.
So interesting question. But this
Mm-hmm.
shows you that vectors is a tough chapter
Mm-hmm.
because not it's not just about vectors anymore. You're using all the ideas you've ever learned, basically. Okay?
Okay. Mm-hmm.
Okay. So you can note this question down and give me 2 seconds. I'm gonna basically kind of plan how to teach you the rest of this because it's about to change a bit, uh, the chapter.
Okay.
Give me like 2 seconds. Okay, so everything good, by the way?
Yep.
All right, are you ready to
Okay.
move on?
Yes, I
Okay.
understand everything.
Let's talk about now position vectors. This is where things are going to slightly change pace in this chapter.
Okay.
What is a position vector? Look, on the xy axis, if you have a point, we've been working with points for a while now, right? Let's say
Mhm.
x1, y1. A position vector is basically a vector that tells you about the position of a point. How? By showing you the vector that goes from the origin to that point. Okay?
Mhm.
So this is called the position vector of A. A line or a vector, sorry, that goes from O to A. Okay?
Okay.
So this is the position vector of A, the point A. Now, what is this vector? It's obvious. It's simply going to be x1 as the first component and
Mhm.
y1 as the second component. So
Mhm.
it's simply the coordinates of the point A. This is the position vector of A x1 y1. So now we've found out that we can actually take a Cartesian question we have, like an
Mhm.
xy axis question we have, and actually convert it to a vector problem by simply looking at every point with respect to its position vector instead of its actual coordinates. Okay, which is
Mhm.
very equivalent. I mean, they are literally equivalent. Okay,
Mhm.
that's one thing. Now another thing is, we can algebraically find the vector connecting two points by using those points' position vectors. What do I mean? Let's say you take a point A, which is 1, 2, and then you take another point B, which is 3, 5, and you
Mhm.
connect, you show them on the graph. A is going to be somewhere here, B is going to be
Mhm.
somewhere here. Okay, this is 1,
Okay.
this is 2, and this
Mhm.
is 3, this is 5. Now,
Mhm.
we can obviously find out what the position vectors of both of these guys are,
Mhm.
like that. Maybe I should have drawn a better there. Okay.
Mhm.
So we can obviously show what their position vectors look like. These are the position vectors that I just drew. However, what if I wanted to find the vector that connects them? We've already
Mhm.
talked about the head to tail method, so we know how to do that, right?
Yeah.
I can
Mhm.
simply go like this and then go like that, and I'll find it. Okay.
Mhm.
But if
Okay.
I try to apply that same rule over here, interesting things happen. Look, if I want to go from the beginning of this red vector to the end of this red vector, then I'll
Mhm.
have to first go in this direction, and then I'll have to go in that direction, right?
Yeah.
So let's write that down. I will have to do minus OA, which is the position vector of A, and then
Yeah.
I'll have to go plus OB, which is the position vector of a B. Why am
Hmm.
I doing minus OA again? Because I'm going opposite to
Yeah.
OA. Remember to
Mhm.
start from the beginning and go to the end. So
Mhm.
something interesting has been concluded here. The fact that to find the vector between any two points A, B, we simply have to find the difference of their position vectors, the ending vector, the ending point
Mhm.
minus the starting point. So this is a general rule now. We can find a vector between A and B by doing B minus A, the position vector of B minus position vector of A. Okay?
Okay.
And this will
Mhm.
be extremely, extremely vital. We're going to use this in almost every single question, like it's just second nature. Okay? It's
Okay.
something just supposed to be the basis of questions at this point. So we can find the vector connecting A to B by simply doing B minus A, or equivalently, B minus A. Okay? So
Mhm.
remember I with I, J with J, just like algebra. 3 minus 1
Okay.
is 2, and 5 minus 2 is 3. So this is your vector. Similarly here, 3 minus 1 is 2, 5 minus 2 is 3. So this is
Mhm.
the vector you end up with. Okay? So which
Okay.
means that this vector has a x length of 2 and a y
Mhm.
length of 3. Okay?
Okay.
So this
Makes
is
sense.
how you can use position vectors to find new vectors connecting any two points. Okay?
Mhm. Okay.
Now we can look at some questions, maybe one question. Let's start with that. Um, this is a good one. So in this question, we have a prism given to us. It's a 3D shape, and we're given a bunch of lengths. We're told that this is 24, this is 20, and this is 7.
Mhm.
And we're told that the unit vector I is pointing in OC direction, the unit vector K is pointing in the OE direction, and the unit vector J is pointing in the OC. Sorry, I is OA and not OC. So I, J, K. Okay.
Mm-hmm.
Another thing that's been told to us is that the point N is dividing the length dB into 2/3, which means that if you divide this whole line into 5 parts, this is
Mm-hmm.
2/5 of that line, and this is 3/5 of that line. Okay.
Yeah.
So this
Okay.
is very important to understand that, you know, do you get this, by the way, how I did this? Because you
Yes, I
broke it
do.
down into a total of 5 parts, 2/5
Yep.
go to dn, and so on. Okay.
Yep.
We need to find the magnitude of dB, which means we want to find this length basically. That's all we're trying to find. Okay.
Mhm. Okay.
Now, this doesn't require any algebra knowledge. You can just understand this is 24 because this is 24 and this is
Hmm.
7. So you can find dB, the length of dB using Pythagoras. Okay.
Yeah.
It will
Okay.
simply be 24 squared plus 7 squared with the square root. So
Hmm.
let's calculate that. We're going to get 24 squared plus 49, which is going to give us 25 as the length. Okay.
Okay.
Now, the reason they ask you to do this is because later now they're going to say, can you find the vector that connects O to N? Okay.
Hmm. Okay.
So we want to find out what this vector is. Okay. So basically we need to go from O to N without going through ON. Okay.
Yeah. Yeah. Okay.
Perfect. So let's figure out some things along the way first. First of all, I can maybe use this path, OE. So I'm going to write it
Hmm.
down. ON is, I can go OE first, and
Hmm.
then ED, and then just DN,
Yeah. Mm.
right?
Yeah.
So this would work. So what is OE? Let's think about it. OE has a length of 7, and it's purely in the direction of K, right?
Mm-hmm.
So that means OE is 0 in the I direction, 0 in the J direction, 7 in the K direction. You see what I did there?
Uh, yeah.
So
I wouldn't know how to do it.
yeah,
But okay.
this is a bit new. So basically think about it like this. I is 1, 0, 0 because it's
Okay.
only one step in the X direction. J is 0, 1, 0 because it's only one step in the Y direction. And
Mm-hmm.
similarly, K is 0, 0, 1 because it's one step in the um, what's it called? Like the Z direction, basically. Okay.
Okay.
So if OE is in the direction of K and nothing else, it's not like it's pointing in somewhere between K and I, for example. It's purely
Mm-hmm.
in the direction of K, right?
Mm-hmm.
They even specified that the unit vector K is parallel to OE, which means that OE is purely directing in the Z direction. Okay.
Mm-hmm. Okay.
And it's 7 long. K is 1 long, but OE
Mm-hmm.
is 7 long. So it's 7 long in the K direction. You can also say 7K, by the way, to be not fancy, I guess.
Mm-hmm.
Okay. So OE is
Okay.
7K. 7 steps in the
Mm-hmm.
K direction, essentially. What about
Mm-hmm.
ED? What direction is ED in? What do you think?
It's 20 long, right?
20 long in what direction?
ED, which
Hmm.
is in the direction of J.
Good job. Exactly. So we'll say, what is ED then?
It is 20J.
Exactly. You getting a hold of it now?
Yeah, I
Okay.
am.
Now,
And
here's the
what if,
problem though. Uh-huh.
sorry, what if I wrote J in that little column thingy? It would be
Yeah.
like
So we could say,
010.
exactly. So we could say it like this, then plus 20 times 0, 1, 0. I'm gonna maybe do it
Mhm.
both ways. Now,
Okay.
here's the problem though. DN. We don't know what DN is because DN is not in the direction of IJ or K. It's somewhere in the middle, right?
Okay. Yeah.
So we need to figure out what DN, like we need to figure out what direction DN is first, right?
Mm-hmm.
And then kind of go from there. So the thing is, DN is in the direction of DB. So maybe we can start by finding the DB vector.
Yeah.
So DN, right? DN is basically 2/5 of DB. Do you agree?
Mm-hmm. Yes.
So we really just need to find out what DB is. We know the length of DB. If we just knew the direction of DB, our life would be saved, right?
Yeah.
So let's
Okay.
try to find DB now. So what do you think? Maybe consider the fact that DB is the same as EA,
Okay.
right? And EA is a bit easier to find because, all of these guys are nearby. So what do you think
Okay.
EA is?
J?
Not just J, because J is this,
Mm-hmm.
right? So we need to start at E and end up at A somehow without going down EA.
Ooh, okay. Um, is it? I'm just finding the direction of
Yeah.
EA.
But you gotta like try to make the vector of EA by like understanding that you know everything around it.
Mm-hmm.
You want to start here. Maybe we should go in that direction first.
Okay.
What is that?
It's negative K?
Not just K. That would just mean like you're going this length.
Negative 7K.
There you go. Negative 7K. And then you want to go down here, so you end up at A.
Mm-hmm.
So plus what? This is I, by the
Plus
way.
24I.
There you go. So now we know
Mhm.
what dB is,
Yeah.
right? So dB is now known to be this. Okay.
Okay.
Which means that since we know that dn is 2/5 of dB, we can say that dn is simply 2 over 5 times negative 7K
Yeah.
plus 24I, which
Okay.
leaves us with that. That is dn. Okay.
Mm-hmm. Mm-hmm.
So we don't need to do this. We can just directly put dn over here now. Okay. So that
Okay.
leaves us with, just a moment. Difficult question, right?
Yeah.
2 over 5
A lot to break down.
minus 7K plus 24I. So again, you
Mm-hmm.
can write down the same thing here as 2 over 5 times negative 7 times 0, 0, 1. That's negative 7K.
Mm-hmm.
And then, just a second. And then plus 24 times I, 100. Okay.
Mm-hmm.
Now
Okay.
we can add all of these together, right? So 7 times 0, 0, 1 is just 0, 0, 7.
Mm-hmm.
This is just going to be 0, 20, 0.
Mm-hmm.
Over here we have minus 7 over 7 times 2 over 5. So minus
Mm-hmm.
14 over 5. Minus 14 over 5 times 1 would just give you 0, 0 minus 14 over 5.
Mm-hmm.
And again, you have 2 over 5 times 24, which is 48 over 5. So you end
Yeah.
up with 48 over 5, 0, 0.
Mm-hmm.
Now you can add these, and these together. The top is 48 over 5.
Mm-hmm.
The middle is 20. And the bottom is 7 minus 14 over 5, whatever that is. And that gives
Okay.
you D and oh no. What does that give you?
O
ON.
O N. Yeah.
Exactly. So tough question, but I
Mm-hmm.
picked a tough one, so don't worry.
Okay.
But yeah, so if you can understand how this works,
Mm-hmm.
you can understand any question that can show up in an exam. Okay. But
Okay.
obviously don't go head first into it. Do some practice questions first.
Yeah.
I'll give
Okay.
you some homework at the end of the class,
That'd be
which
good.
is now actually I just realized.
Mm-hmm.
Um, Time flew. So let me
Yeah.
stop recording. So by the way, this basically so far we've only covered everything just before vector equations. There
Oh.
is scalar product yet to
Mm-hmm.
do, and then vector equations. And vector equations is the last thing, which is pretty
Mm-hmm.
complicated. So I would highly suggest that we, kind of practice this stuff first and then
Yeah.
move on to vector equations. We'll maybe do like 20 minutes of practice questions in the next class first. Okay?
Okay. Sounds good.
And yeah, so I'll send you some questions now for homework, and that's basically it.